Welcome back, and by now you should understand the difference between stateless and stateful security protection. In this lesson, I want to talk about one security feature of AWS VPCs in a little bit more depth, and that's network access control lists known as NACLs. Now we do have a lot to cover, so let's jump in and get started. A network access control list can be thought of as a traditional firewall available within AWS VPCs. So let's look at a visual example. A subnet within an AWS VPC which has two EC2 instances, A and B. The first thing to understand, and this is core to how NACLs work within AWS, is that they are associated with subnets. Every subnet has an associated network ACL, and this filters data as it crosses the boundary of that subnet. In practice, this means any data coming into the subnet is affected, and data leaving the subnet is affected. But, and this is super important to remember, connections between things within that subnet, such as between instance A and instance B in this example, are not affected by network ACLs. Each network ACL contains a number of rules, two sets of rules to be precise. We have inbound rules and outbound rules. Now, inbound rules only affect data entering the subnet, and outbound rules affect data leaving the subnet. Remember from the previous lesson, this isn't always matching directly to request and response. A request can be either inbound or outbound, as can a response. These inbound and outbound rules are focused only on the direction of traffic, not whether it's request or response. In fact, and I'll cover this very soon, NACLs are stateless, which means they don't know if traffic is request or response. It's all about direction. Now, rules match the destination IP or IP range, destination port or port range together with the protocol, and they can explicitly allow or explicitly deny traffic. Remember this one, network ACLs offer both explicit allows and explicit denies. Now, rules are processed in order. First, a network ACL determines if the inbound or outbound rules apply. Then it starts from the lowest rule number. It evaluates traffic against each individual rule until it finds a match. Then that traffic is either allowed or denied based on that rule, and then processing stops. Now, this is critical to understand because it means that if you have a deny rule and an allow rule which match the same traffic, but if the deny rule comes first, then the allow rule might never be processed. Lastly, there's a catch-all showed by the asterisk in the rule number, and this is an implicit deny. If nothing else matches, then traffic will be denied. So those are the basics. Next, let's move on to some more complex elements of network ACLs. Now, I just mentioned that network ACLs are stateless, and this means that rules are required for both the request and the response part of every communication. You need individual rules for those, so one inbound and one outbound. Take this example, a multi-tiered application running in a VPC. We've got a web server in the middle and an application server on the left. On the right, we have our user Bob using a laptop, and he's accessing the website. So he makes a connection using HTTPS, which is TCP port 443, and this is the request, as you know by now, and this is also going to mean that a response is required using the ephemeral port range, and this ephemeral port is chosen at random from the available range decided by the operating system on Bob's laptop. Now, to allow for this initial communication, if we're using network ACLs, then we'll need to have one associated with the web subnet, and it will need rules in the inbound and outbound sections of that network ACL. Notice how on the inbound rule set we have rule number 110, which allows connections from anywhere, and this is signified by 0.0.0.0/0 through this network ACL. and this is allowed as long as it's using TCP port 443. So this is what allows the request from Bob into the web server. We also have on the outbound rule set rule number 120, and this allows outbound traffic to anywhere, again 0.0.0.0/0, as long as the protocol is TCP using the port range of 1024 to 65535, and this is the ephemeral port range which I mentioned in the previous lesson. Now this is not amazingly secure, but with stateless firewalls this is the only way. Now we also have the implicit denies, and this is denoted by the rules with the star in the rule number, and this means that anything which doesn't match rule 110 or 120 is denied. Now it's also worth mentioning, while I do have rule 110 and 120 numbered differently, the rule numbers are unique on inbound and outbound, so we could have the single rule number 110 on both rule sets, and that would be okay. It's just easier to illustrate this if I use unique rule numbers for each of the different rule sets. Now let's move on and increase the complexity a little. So we have the same architecture. We have Bob on the right, the web subnet in the middle, and the application subnet on the left. You know now that because network ACLs are stateless, each communication requires one request rule and one response rule. This becomes more complex when you have a multi-tiered architecture which operates across multiple subnets, and let's step through this to illustrate why. Let's say that Bob initiates a connection to the web server. We know about this already because I just covered it. If we have a network ACL around the web subnet, we'll need an inbound rule on the web network ACL. There's also going to be response traffic, so this is going to use the ephemeral port range, and this is going to need an outbound rule on that same web network ACL. So this should make sense so far. But also the web server might need to communicate with the app server using some application TCP port. Now this is actually crossing two subnet boundaries, the web subnet boundary and the application subnet boundary. So it's going to need an outbound rule on the web subnet NACL and also an inbound rule on the application subnet NACL. Then we have the response for that as well from the app server through to the web server, and this is going to be using ephemeral ports. But this also crosses two subnet boundaries. It leaves the application subnet, which will need an outbound rule on that NACL, and it enters the web subnet, which will also need an inbound rule on that network ACL. And what if each of those servers needs software updates? It will get even more complex really quickly. You always have to be aware of these rule pairs, the application port request and the ephemeral response for every single communication. In some cases you're going to have multi-tier architecture, and this might mean that communications go through different subnets. If you need software updates, this will need more. If you use network address translation or NAT, you might need more rules still. You'll need to worry about this if you use network ACLs within a VPC for traffic to a VPC, or traffic from a VPC, or traffic between subnets inside that VPC. When a VPC is created, it's created with a default network ACL, and this contains inbound and outbound rule sets which have the default implicit deny, but also a catch-all allow, and this means that the net effect is that all traffic is allowed. So the default within a VPC is that NACLs have no effect, they aren't used. This is designed to be beginner friendly and reduce admin overhead. AWS prefer using security groups, which I'll be covering soon. If you create your own custom network ACLs though, that's a different story. Custom NACLs are created for a specific VPC, and initially they're associated with no subnets. They only have one rule on both the inbound and outbound rule sets, which is the default deny, and the result is that if you associate this custom network ACL with any subnets, all traffic will be denied. So be careful with this. It's radically different behavior than the default network ACL created with a VPC. Now at this point I just want to cover some finishing key points which you need to be aware of for any real-world usage and when you're answering exam questions. So network access control lists, remember they're known as NACLs, they are stateless, so they view request and response as different things. So you need to add rules both for the request and for the response. A NACL only affects data which is crossing the subnet boundary, so communications between instances in the same subnet is not affected by a network ACL on that subnet. Now this can mean that if you do have data crossing between subnets, then you need to make sure that each NACL on both of those subnets has the appropriate inbound and outbound rules. So you end up with a situation where one connection can, in theory, need two rules on each NACL if that connection is crossing two different subnet boundaries. Now NACLs are able to explicitly allow traffic and explicitly deny, and the deny is important because, as you'll see when I talk about security groups, this is a capability that's unique to network ACLs. So network ACLs allow you to block specific IPs or specific IP ranges which are associated with bad actors. So they're a really good security feature when you need to block any traffic attempting to exploit your systems. Now, network ACLs are not aware of any logical resources. They only allow you to use IPs and side arranges, ports and protocols. You cannot reference logical resources within AWS. And NACLs can also not be assigned to logical resources. They're only assigned to subnets within VPCs within AWS. Now, NACLs are very often used together with security groups, as I've just mentioned, to add the capability to explicitly deny bad IPs or bad networks. So generally you would use security groups to allow traffic and you'd use NACLs to deny traffic, and I'll talk about exactly how this works in the next lesson. Now each subnet within a VPC has one NACL associated with it. It's either going to be the default network ACL for that VPC or a custom one which you create and associate. A single NACL, though, can be associated with many different subnets. So while a subnet can only have one network ACL can be associated with many different subnets. Now at this point, that is everything that I wanted to cover about network ACLs for this lesson. So go ahead, complete the video, and when you're ready, I'll look forward to you joining me in the next lesson.